Hi everyone. Today we're going to be talking about notes 6.5, which is taking polar form still, and we're going to still be using complex numbers, but this time we're going to be doing and finding the products and quotients in polar form. So again, products, just as a review, products has to deal with multiplication. So I'll put an X under here to stand for multiplication. And then quotients is the opposite, which is of course division. So we're going to be multiplying polar form and dividing in polar form today. In front of you we have two formulas. We have the product formula and the quotient formula. And so what happens is I'm going to be giving you these pieces. I'm going to say z sub 1 equals all of this, and z sub 2 equals all of this as well. And I'm going to ask you, if I were asking for the product, I would ask you to multiply them together. And so if you look carefully at the formula, you're going to take all of the bits and pieces from each section, and you're going to follow what the product or what the formula is going to tell you to do. So for example, all of your R1s and R2s are going to multiply in the front, followed by brackets, and then what you do with your angles is very similar to your exponential rules. When you're multiplying, your angles are going to add together. So whatever your original angle 1 was going to be, plus your original angle 2. All right, and again, I'm going to give you those. All it is just a plug it in and figure it out. Same thing for the quotient. If we move down here, taking a look at this formula, if I asked you to find the quotient of two things, you are of course dividing. So the first thing you would start off with is dividing your R1 and your R2 from each section that I gave you. But then when you get to the angles on the inside, you're not going to add this time, you're actually going to subtract. So again, very similar to exponential rules. When you multiply with exponents, the exponents get to add. When you divide with exponents, the exponents subtract. Same thing here, except we're talking about angles instead of the exponents. Okay. Have a look at your golden ticket, your formula sheet. Both of these should be on there. Make sure you can identify them and know where they are. They are labeled as quotient and product, so make sure you can tell the difference between both. The other thing we'll need for today is your unit circle, or you should know it by now. So I challenge you to put the unit circle away and let's try remembering it. See how far you can go with your remembering. All right, so we're going to use these two formulas depending on what I ask you to do for each question, and you'll see how they work out. So we'll start with question 1. The directions say find the product or quotient in terms of I. So our final answer should have an I in it, an imaginary number, because we're talking about complex numbers. And then express the result as a complex number in polar form. So if you remember from the last section of notes, complex numbers in polar form are always A plus BI. We're going to have a real number plus an imaginary number. So that's what we want our final answer to look like. So we do want an I in the end, so don't lose it in the formula. So let's get started with question 1. We have 4 parentheses cosine 50 degrees plus I sine of 50 degrees times 7 parentheses cosine of 100 degrees plus I sine of 100 degrees. So what I want you to pay close attention to is right here. Identify what we are actually doing with these two terms. We are multiplying, so we need to find the product. When I look up at my product formula, it tells me, and I'll just write it here so you guys can use it as a reference, it tells me that the product of Z1 times Z2 is going to equal R1 times R2, parentheses, cosine of angle 1 plus angle 2 plus I sine of angle 1 plus angle 2. Okay, they use brackets. I'm just using another set of parentheses, but it's the same idea. And now all we need to do is plug things in. So the Z1, Z2, that's just the multiplication, so we'll leave that as is. My R1 is going to be the first R in front of those parentheses. So that gets swapped out with a 4. Multiplied by my R2, which is 7 in front of those parentheses. So I'm going to make sure those two numbers get multiplied. And then on the inside of my parentheses, I'm going to keep the cosines. But when I get to the angle portions, I'm taking cosine of 50 degrees, adding it with 100 degrees. So I have 50 degrees plus 100 degrees. And I'll do the same thing with sine. You'll notice that the angles for both of these should always match. You should never be changing anything like that. You'll notice in the originals, both angles in both sections are sine 50 and cosine 50, and the other one are the same, cosine 100, sine 100. So let's go ahead and clean things up really quick. 4 times 7 on the outside there is going to give me 28. When I add my angles together, I'm going to get 150 degrees, which is nice because I know that exists on the unit circle. And then I get sine of 150 degrees. Again, they should match. Now what I have to do is ask myself, well, what are those values on the unit circle? What is my cosine at 150 degrees? And what is my sine? So again, I challenge you to not use your to not use your unit circle and try using your memory here. So cosine of 150 is in quadrant 2. That means it's got to be negative. And if I remember my 150, that gives me negative root 3 over 2. Plus, and I will keep my I, and my sine at 150 is positive in quadrant 2, and it's 1/2. Of course, don't forget your 28 is still out front. And now we go and we distribute that in. So 28 times negative root 3 over 2, that's going to cancel, leaving me with negative 14 root 3. And then when I get to the second one and distribute, that's going to leave me with a positive 14i. And that, my friends, will be our final answer. Again, this is in a plus bi form. You have a real number followed by an imaginary number. So we know we are good there. All right. Square roots, yes, they're not ideal, but it still can happen. So we are fine there. Go ahead and we're going to try question 12 now, or excuse me, question 2 now. All right. However, we're not going to multiply this time. We are actually going to divide, which means we want to use the quotient rule. And as a reminder, the quotient rule tells you to divide your r's this time instead of multiply. And then when we get to the angles, we are going to subtract them instead of add them because we are dividing. So to get started, I'll take my two r values and divide them. Make sure that the first r is the top number. That is important, okay? The first one is the first part of your fraction every single time. Then I'm going to get to the insides. And I have cosine of 3 pi over 4. And I get to subtract that with pi over 4. Followed by plus I sine, with the same two angles getting subtracted. Clean things up a little bit. 12 divided by 4 gives me 3. When I subtract my angles, they have a common denominator, which is nice. That will now give me 2 pi over 4. But of course, we know that 2 pi over 4 can simplify and give me pi over 2. So simplify when you can, because that will be on the unit circle much nicer than 2 pi over 4. And less room for confusion. All right, so now that I have my real angles that I'm talking about, we're looking at pi over 2. Again, going off of memory, cosine at pi over 2 should be 0. And sine at pi over 2 should be 1, with my 3 still out front. And when I go to multiply, I should have 3 times 0, which is just 0. And then 3 times I times 1 just gives me 3i. Okay. This is still in a plus bi form. Just as a refresher, my a technically for this one is 0, while my b would be a positive 3. So if you were wondering if that is in complex form, it is indeed, and you are good to go. If you would like to pause the video and get going on these questions, you may do so. Give yourself some time, see how you do, and then come back to the video. We only have 2 questions left, so see if you can work these ones out. For question 3, again, we're finding the product, so I'm going to make sure to use the product formula on my golden ticket. That tells me to multiply my 3 and 2 together, and then my angles 7 pi over 6 and 2 pi over 3 also need to get added together. According to this formula, that is what it tells me to do. Clean it up a bit. 3 times 2 is going to give me 6. And when I get to my angles, they don't have a common denominator, so let's fix that. Let's get a common denominator of 6, and then that will change my numerator here to a 4. So now when I add them together, I'm looking at 11 pi over 6. Again, that's still on the unit circle, so I know I'm good. I can do the same thing on my second angles here, which again should be the same exact angle at the end. So 11 pi over 6. And then if I look and think of my angles, and I remember the unit circle, I'll bring down my 6. Cosine at 11 pi over 6 is going to be a positive 3 over 2. Followed by sine at 11 pi over 6, and that is negative 1/2. Go in and distribute that 6 now. It will cancel, leaving me with a 3 in the numerator and a 1 in the denominator. And then in the second one, I'll be left with a negative 3i when I distribute. Again, it is in complex number form. We are good to continue. And for question number 4, we're dividing again, so we want to divide my r's, making sure that 12 is first, followed by 4 underneath. And then when I get to my angles, I'm going to end up subtracting. When I go to clean up, 12 divided by 4 gives me 3. And when I get to my angles this time, when I find a common denominator, it's going to give me negative 5 pi over 4. All right. You can do this one of 2 ways. We've discussed it in class already. You can choose to find 5 pi over 4 in the unit circle and then work backwards. So if 5 pi over 4 was in the 3rd quadrant as a positive angle, you would work backwards going clockwise to 3 quadrants clockwise. So you would end up in quadrant 2, which would put you at 3 pi over 4. Now, if you don't like to do that and you want to look at just your angles and make them positive, let's take a look at negative 5 pi over 4, and just off to the side here, I'm going to ask myself, well, what is that same angle but on a different rotation of the circle? I don't want to use negative 5 pi over 4 because I don't know how to find it. I don't want to work backwards. I don't want to look to my unit circle, yada, yada, yada. I want something that actually truly exists on the unit circle. So what I'm going to do is I'm going to add a rotation. And what that means is I'm going to add a full circle back, which is, of course, 2 pi. Get a common denominator, fix the numerator. And now when I get to add them together, I'm really looking at 3 pi over 4. And what that means is I can take those angles that I had originally, that negative 5 pi over 4, and I can change it to just a positive 3 pi over 4. It's still the same exact thing, same exact location on the unit circle, but now I have an actual value that exists on the unit circle and I won't be as easily confused. So I'll go from here and I will swap them out with my unit circle values. Cosine at 3 pi over 4 is negative root 2 over 2. And sine at 3 pi over 4 is a positive root 2 over 2. And last but certainly not least, I will go in and distribute, leaving me with negative 3 root 2 all over 2 plus 3I root 2 all over 2. It is still in A plus B order. It's still a complex number where I just have a lot more values with that square root and everything else, but it is still possible. All right. So these are your notes for 6.5b. Again, there's only 2 formulas. You will have them on your golden ticket on your formula sheet for your test. Just make sure you know how to interpret each formula so that your product is adding your angles and multiplying your r's in the front, whereas your quotient is dividing your r's in the front and subtracting your angles. So make sure you know how to interpret those functions